Okay, good morning, pilot teachers and students. Good morning, class. Okay, thank you. You may sit down. Right, we are only going through the revision, and part of our revision will be on errors in science. Okay, looking at errors, what are errors? Maima, can you tell us? Okay, good. Errors and mistakes we make in measurements. Right. In here, I have different types of errors which are being stated here. The first one is random error. All right, we can simply see here that when making measurements in science, there are two basic type of errors that we make or that may occur. Right, they are namely the random and also the systematic error. All right, firstly, let's have a look at this random error. These are irregular errors that sometimes make the reading too large and sometimes too small. Right, they may occur because of difficulty in reading small-scale divisions on a scale or because of other random factors. For example, if a ruler that is made for the temperate region, if you are trying to measure the temperature there, but if you have to take that ruler to, let's say, the tropics, it will have to expand because the ruler is made of metal. So the grading should be either too large or too small. Right, this is also another random factor. Right, sometimes we can sometimes call these errors as human errors. Okay. Now the next type of error is simply the systematic error. And these errors are usually instrumental errors or always give the same size of the error for the same magnitude that is measured. For example, you may have a pointer, let's say of an ammeter that is at or above 0 when you started the ammeter reading. So that means that number that is above that 0 will be included on the measurement. And sometimes it will give you the same magnitude. Okay, this is for that. And looking at these errors, the parallax and also the zero errors, you'll find that the parallax errors occurs when reading is taken at an angle, meaning that the reading is when the reading is taken, it is not at 90 degrees to the scale. You are not reading it in line with the scale. That is why we may arrive with this kind of errors, which is known as the parallax error. Now, looking at the zero error, right, this may happen when a pointer is reading. When this point reading is taken, it is not at 0. Say a voltmeter or ammeter reading, which may not give you an accurate reading. Examples include a ruler. One of these rulers. For example, if you are trying to measure the length of, let's say, at top of the desk, if you start this one on 1, right, that means 1 will be also included in the measurement that you take. Let's say this is 0 up here, and you decide to take the reading starting from 10. If you try to take that measurement, it will give you the same size or the magnitude at which you are trying to measure. Because it is not on 0 when you started or taking the reading. All right, in here, I have some activity for you, but before we go to that, I will explain to you how you can solve question number 2 for this one. Let's say, for example, the following 5 lengths of measurement are given, okay, here. If in any cases, if you were given something like this, you will have to add all of these to come up with a estimate or the average of those measurements. Right, using that average, you can now minus it from the largest measurement that is given, and that gives you the size of the error. Using that size of the error, you can calculate the fractional error or the percentage error. Okay, that percentage error is sometimes known as the relative error. Okay, so you can quickly go through and then copy this one. After you copy this one, I will ask you to copy the notes. For those who have not copied the notes, you can copy this activity. After this activity, I will ask you to go through and then copy those notes on errors. All right, for those students who have not taken the notes, especially pilot students, right, I will be asking you now to go through and then copy these notes down quickly, right? But especially for those pilot students who are taking down the notes, you'll find that there are basically two types of errors that we can see. Okay, they are the random and also the systematic error. But then the last two has parallax error and also zero errors. These two can simply come under either in one of that, which is systematic error, or random errors. This is Sunny working out. You go for question number 1. Yours is question 1. Yours is question 1. Question 1. And we go for question number 2. Go for question number 2. Okay. 1, 1. Yeah. And then 2. You go for the question number 2A. We'll go for question number 2A. Question number 2A. Go for question 2A. Here. Who is going to go for question number 2? 2B.
Say that or we will write it?
Okay, you can just go and then explain, say, write it and then say it. Why do you think so? It happened that way. Okay. Okay, same to you. You go out there, write it on the side, then you say that why you think it is that. Okay. 2B will be now. Question number 2B will be yours. Okay. Joseph, you go for C. Question 2C will be yours. And okay, you go for question 2D, percentage error. Okay. Size. How do you calculate the size of the error? You explain. You take the highest, after finding the average highest score, what is the highest score in there? Okay, you minus it from the average to give it a size, and then you write it, if it is the average, plus or minus something, something, something. Okay, you go for the percentage error. Joseph, B will be yours. Question 2B. Yeah. You know how to write that one? You minus it from the, how do you find? Yeah. Minus the average, and then you get the size of the error. And then you write it down as plus or minus. Okay, that figure, this size are the average plus or minus the size of the error, plus or minus. Okay? Which one? This? What is the fractional error? Okay, maybe two places, yeah.
All of them. I didn't leave one of them out. Is that okay?
Hmm? Which one?
So I didn't leave any of them out. I decided
You add them up and then you come up with the average. Okay. Yeah.
divide it by 5.
That's right. Okay, good. Percentage fractional. Okay. Okay, just write this as fraction.
Not this one.
No, this one. This one will be 100 over 1. What is the time, man? Here's the bell cone for already. Okay, we will now go through the correction of those activity questions. All right, the first one. Okay, Mark. Second question will be John. Third, Charlton. Fourth will be. Okay, that is for question number 1. 1 will be you. Okay, you can write if you want to.
It's a systematic error because the spring balance that has been used, there's some faulty on it.
Okay, plus is that answer correct? Okay, yes, the answer is correct. For the first one, uneven intervals on a spring balance would be systematic error. Okay, write the answers there.
is a random error because the scales were too small to read for the read.
Right, for this first question, number 2, we find that the answer was random error. Okay, simply that is correct because the scale divisions were too small to read, and probably if you are colorblind, you may not read those scale divisions. So it is A, okay, random error. Okay.
Firstly, I got divide the scores by 4 to get the average.
Right, good. The average is 14.9. Is that correct? All right, yes. So you have to add all of these. There are 4 scores divided by the number of scores, which is 4. And then you arrive with, it is 14.9. Okay, for question number 2, who can give us the, okay, number 2B, who can give us the size of the error? Okay, you can use this side.
I got 15.2 from the highest measurements.
Put the book.
I got 15.2, which is the highest length measurement. 14.9 the average. I minus that, I got 0.3. So the answer is 14.9 plus or minus 0.3.
Okay, very good. So the size of the error is about 0.3, and then you have 15.2, which is the highest score minus the average, and then you come up with 0.3. And that 14.9 plus or minus 0.3. So it can be plus 0.3 on top of this, or it can be minus 0.3 below this average. Okay? Okay, now on to the fractional error. Okay, calculate the fractional error.
To get the fractional error, you have to divide the size of the error over the average. It's
Okay.
0.3 over 14.9, and you get 0.02.
Okay, that when you were speaking, you stand on this side.
So what should I do?
Okay. Okay, very good. Okay, quickly to go through this one. All right, that is the fractional error. Simply getting the size of the error, which is 0.3 over 14.9, and then you get this. Okay, that is correct. And finally, to the percentage or the relative error, we have 0.3 over 14.9 times 100, and that will give us 30 over 14.9, and the answer will be 2.013. And then you have lots of numbers. So when you round it, it's 2%. So using this 2%, you can now estimate whether you are more accurate or you have made a little bit of error or mistakes. Okay? So simply when you are looking at errors, they may come under two types. The first one is simply a random error, and also the systematic error. This error occurs because of faulty machines that we are trying to use in measuring any physical quantity. Okay, and this one is sometimes because of human errors. Maybe there is some errors because of us. Okay, we may not be using that machine more correctly. Right, these two are zero errors and parallax. You will find that sometimes these two may either come or fall into these two types of errors, systematic and also the random errors. Right, that brings us to the end of our lesson. Our keyword for today is errors in science. Right, once again, good afternoon, pilot teachers and students. Good afternoon, class. Good afternoon, sir. Thank you. Please sit down.